Goregaon MPS Municipal Secondary School East. I'm going to continue with the topic of periodic classification of elements from the subject Science 1. So let's start with our topic. We will revise the topic which have been studied yesterday in short. So yesterday we have seen about types of matter, water matter. Then in that different types of matter, pure substances, impure substances, elements, compounds. Then after that we have studied that how the classification of elements takes place. Then three of the scientists, one of them is Doberian and Triads. Then how the triad classification has been done. Triad classification have been done according to the increasing atomic mass of the elements. They have been arranged, and after that we have to find out first the mean of the first and the third element, and after that whatever the answer we will get, that will be the atomic mass of the second element or the middle element. That is known as the triad. Then few of the list of the triads we have seen. Then after that demerits of Doberian triads we have seen yesterday. After that, Newland's law of octaves we have seen yesterday. So how, depending upon the notes of the music, he arranged the elements as the element of the eighth element should be placed below the first element, as it shows the similar chemical properties. After that, few of the examples of Newland's law of octaves, and in that too, few of the demerits have been recognized. After that, Dmitry Mendeleev also proposed one of the classification of elements. He arranged it, but because of the presence of few of the demerits, it was also not useful to some extent. So later on, it was necessary to use the another method, or to classify the elements with the another method of modern periodic table. Now after that, the modern periodic table have been established. Now modern periodic table consisting of the main thing from the scientists which were studied yesterday. We have studied yesterday with the Doberian and triads. This table considering all the classification which was done yesterday, from that it has been taken. So the modern periodic law states that the physical and the chemical properties of the element are the periodic function of their atomic numbers. Now the scientists arrange the elements in the increasing order of their atomic numbers from left to right across each row, and discovered that the elements having similar chemical properties repeat after regular intervals. So after that, in 1913 AD, the English scientist Henry Moseley demonstrated with the help of the experiments done using the X-ray tube that the atomic number of an element corresponds to the positive charge on the nucleus or the number of protons in the nucleus of the atom of that element. So this revealed that the atomic number is a fundamental property of the element than its atomic mass. So previously, whatever the scientist had recommended that atomic mass is important for the arrangement of elements, it has been denied, because then afterward, Sir Henry Moseley experimented and demonstrated that atomic numbers are necessary to arrange the elements, to classify the elements. So whatever the classification of elements have been put forth by the scientist Doberian triads, after that Newland's octave, and after that Dmitry Mendeleev. All these scientists, they used the atomic mass numbers, but here in the modern periodic table, atomic number have been used to arrange the elements. So this has been this shows many of the increasing property of the elements. Then after that, as the number of atomic number increases, their properties and how they are arranged, all these things have been put forth in the modern periodic table. So the properties of elements are the periodic function of their atomic numbers. This have been recognized. So the modern periodic law states that the physical and the chemical properties of the elements are the periodic functions of their atomic numbers. So previously it was atomic mass, but now in the modern periodic table it has been put forth that atomic numbers are important. Then scientists arranged elements in increasing order of their atomic numbers from left to right, okay, across each row, and discovered that the elements having the similar properties repeat after regular intervals. They repeat after regular intervals of time. So when they get repeated, it has to be kept below the first one, which shows the similar chemical properties of that of the other element. Now you can see here, this is the general table of modern periodic table. From this you will understand the elements which are arranged in whatever the columns or the rows, we will consider it what. Okay, so here you can see on the left hand side, the column which is written, they are all considered to be the alkali metals. After that, alkaline earth metals are there. So whatever elements will be there in those columns, all will be the alkaline earth metals. Then after that, in the middle, whatever elements will be there, they all are transition metals. Okay, so you can understood that alkali metals, alkaline earth metals, and transition metals. The word metals are coming, so these are all the metals here. After that, the gray part, it consists of metals, non-metals, and metalloids. So metals are very less here, but non-metals and metalloids are more in number in this arrangement. Then after that comes the halogens. You know the halogens: fluorine, chlorine, bromine, iodine. These are all the halogens. After that, noble gas elements. So as you know, argon, krypton, helium, neon. These are all the noble gas elements. Then below it is given lanthanide metals and actinide metals. Now these lanthanides and actinides, they came from the in the transition metals, lanthanide element is there, and below that actinide element is there. But few of the elements have been discovered later on, which shows the similar properties of the lanthanide, like that of the lanthanide metals. So they are known as the lanthanide series. So that's why the different type of below, they have to increase their number of elements, because they all show the similar properties like that of the lanthanide metal. So these are known as the lanthanide series, and whatever the elements which are present uh, after the actinide metals, they are known as actinide series. So they have to keep below, because place was not there, and few of the places already left by the Mendeleev, as we have studied yesterday, that Mendeleev have kept few of the vacant places to keep whatever the elements which were discovered later on, they can keep there and we can study it. So the classification of the elements resulting from an arrangement of elements in an increasing order of the atomic mass is the modern periodic table. Now this is the modern periodic table. This is the general modern periodic table. Now here you can see, now first of all, above you can see here alkali metals. They are shown in blue colors. Okay. Then transition metals, few of the they are orange colors. Then noble gas, then actinoids. Then after that, alkaline earth metals, sky blue color is given. Non-metals, green colors are given. Lanthanoids and other metals. Lanthanide and actinide series, they are given below. Now this is the general modern periodic table which have been given to you, and you can see S block elements, then P block elements, D block elements, and F block elements. Arrow is given on the left hand side, arrow is given. So you can say that the alkaline metals and alkaline earth metals. So here you can see here alkaline metals and alkaline earth metals, they all come in S block elements. Then again you can see the D block elements. D block elements are nothing but the transition metals. They all contains transition metals. So here you can see. Then after that, on the right hand side, P block elements are there, which include noble gas elements also, halogens also. So here you can see whatever the right hand side part is there, that arrow is given upwards. So halogens, noble gas, and this gray color part, these are all nothing but the P block elements. Then the below you can see lanthanide series and actinide series are given. They are all F block elements. Here you can see lanthanide metals and actinide metals. Now, in the so here the properties of the elements can be predicted more accurately with the help of the modern periodic table formed on the basis of the atomic numbers. So the modern periodic table is also called as the long form of the periodic table because it was much in detail. Okay, so as a result, most of the drawbacks of the Mendeleev periodic table, they are removed here. So the position of the hydrogen is not removed even in the modern periodic table, the ambiguity. Okay, so after that we have seen that the way in which the electrons are distributed in the shells around the nucleus is determined by the total number of electrons in it, and the total number of electrons in an atom is same as that of atomic number. Now we know what do you mean by the atomic number. As I already told you that atomic number is nothing but the number of electrons or the number of protons, because whatever will be the number of electrons, same number will be the number of protons. Protons are present in the nucleus. Now you know that atom consists of two parts. One is the electrons which is revolving around the nucleus, and in the nucleus part it is present protons and neutrons. Now number of protons and number of electrons both are same. Okay, now so the atomic number is the nothing but the number of electrons or the number of protons. Okay, I'm keeping or there in between. Okay, so either you can write it number of electrons or you can write number of protons. And what do you mean by the atomic mass number? Atomic mass number is nothing but the number of neutrons plus the number of protons, as the mass of an atom is concentrated in its nucleus. So that's why the number of protons plus number of neutrons is nothing but the atomic mass. So here in the modern periodic table, we considered only the atomic number, and on the basis of the atomic number, we arranged all the elements here. Okay, so atomic number is the number of electrons which are revolving around the nucleus or the number of protons which are present in the nucleus. So the relationship between the atomic number of an element and its electronic configuration is clearly seen in the modern periodic table. Now here in the periodic table, you can see the modern periodic table contains 7 horizontal rows called the periods from 1 to 7. Now vertical rows, vertical columns, and horizontal rows, okay. Now here you can see here below that S block element 1 and 2 is written. Okay, 1 for the first column, 2 for the second column. So these are all the numbers for the groups which are till 18. On the right hand side you can see for the noble gas elements till 18 it is given. These are all the number of groups here. Okay, so these are all the vertical columns and it consists of 18 groups. And periods, how many periods are there? You can see horizontal rows. Horizontal rows means count from hydrogen. Hydrogen 1, lithium 2, Na3, K4, Rb5, Cs6 and Fr7. So these are all the horizontal rows. Now hydrogen, hydrogen horizontal line consists of hydrogen and helium. This is one period. Then lithium series, that lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. These are all in the second period. After that sodium, magnesium and all, aluminium, silicon, phosphorus, sulfur, chlorine, argon, these are all in a third period. After that potassium, these are, and whatever the elements present after that, these are all in the fourth period. Then Rb, fifth period, Cs, sixth period, and Fr, seventh period. So here horizontal rows, these are all periods, and vertical columns, whatever the vertical column is there. Now in vertical column 1, okay, group number 1. Group number 1 consisting of alkali metals, that is hydrogen, lithium, sodium, potassium, Rb, Cs, Fr. So these are all in a group 1. After that group 2 is there. After that 3, 4, 5, 6 till 18. So these all are vertical columns. These are all groups. So there are 18 vertical columns in the table, and the group name is, and the group number is from 1 to 18. So the arrangement of the periods and the groups resulting into the formation of boxes. So atomic numbers are serially they indicated in the upper part of its boxes. So each box corresponding to the place for one element. Apart from these 7 rows, 2 rows are shown separately at the bottom of the periodic table. And these are known as the Lanthanide series and Actinide series. Okay, so here you can see Lanthanide and Actinide series, which are shown separately, and below that F block is written. So there are 118 boxes in the periodic table, including the 2 series. So it means that there are 118 places for elements in the modern periodic table. So very recently, formation of a new element was established experimentally, and thereby the modern periodic table is now completely filled. So all the 118 elements are now discovered. So the entire periodic table is divided into 4 blocks: S block, P block, D block, and F block. Now, S block consists of first and second group. Then D block consisting of from group 3 to 12, that is known as the transition metals, as I already told you before. After that, from group 13 to 18, which consisting of metals, non-metals, metalloids, and noble gases. These are all considered in a P block elements. After that, below Lanthanide and Actinide series are there, and it is consisting in, they are consisted in F block elements. Okay, so now here you can see the 3 traditional types of elements can be clearly shown in the modern periodic table with the help of this zigzag line. This zigzag line you can see here, that from B, Si, As, Te, and At. Now here non-metals are there, green colored. Okay, now here you can see here, boron, then silicon. I'm just going sloping line or slanting line is there. No, so likewise you can go from boron. After boron, silicon. After that, As, Te, At. So these are all considering of it is zigzag line. Okay, they are considered in a zigzag line. So the metalloids elements lie along the border of this. So all the metals lie on the left hand side, and the non-metals, they are lying on the right hand side of it. I will show you. Okay, so now you can see here groups in the modern periodic table. Now here the groups are given, groups and families. So first group, alkali metals. Okay, second, alkaline earth metals. From 3 to 12, transition metals is there. 13, boron family group is there. Then 14, carbon family, you can see here. 13 is boron family. So you can see whatever the elements present below boron, they are all boron family. After that, whatever the elements present below carbon, they are all considered in carbon family. Whatever the elements present below nitrogen, they are all considered in nitrogen family. Okay, then 16, oxygen family or chalcogens family. Okay, 16 one. Here you can see oxygen, or it is also known as halogens because it is present before halogens. That's why the name is given. Okay, and after that halogen group is there, and after that noble gas, which is the most stable element, which does not react with elements. It can react, but if further drastic condition is applied, then only it can react, because these are the most stable elements. They are stable in itself, so that does not require any other element to react with it. Then after that, 17th is halogen and 18th is noble gas elements. You can see from this table. Now groups and electronic configuration. Now, as you know that within a period, the neighboring elements differ slightly in their properties, while distant elements differ widely in their properties. Okay, here you can see here. Now, suppose lithium is there, and I considered another element, fluorine is there. Okay. Now, here in this case, you can see that lithium is a metal and it contains the property of the metal, whereas the fluorine is a non-metal and it will consider the property of a non-metal because it is a halogen, isn't it? So all these elements, the elements which are present far away from each other, they are differ in chemical properties. Okay, so here whatever the elements which show similar chemical properties, they are present in one group. Okay, so the first group they all contain the similar properties. That's why they are placed one below the another. Second group contains similar properties. That's why they are placed one below the another. Likewise, in the periodic table, whatever the vertical groups are there, vertical columns are there. Whatever elements are placed, they all show similar chemical properties. Okay, now lithium and beryllium, they show the chemical property near about similar. Okay, to some extent they are different, but most of the properties are similar. Most of them, not all, but most of them. So that's why uh, they are placed together. That means after lithium, beryllium is given. Their groups are different, but still they show most of the similar properties. That's why they are placed one after another. Okay, that so this is the arrangement of the model periodic table. And if it is if the element is having very different chemical property, that is placed far away from each other. Okay, now here you can see according to the group 1. Okay, now here yesterday I shown you one periodic table and their Roman numbers were written. Okay, first A, second A. Okay, then for boron family, third A, carbon family, fourth A. So why these Roman numbers were given? Yesterday I told you that these Roman numbers indicate the number of electron which is present outside the nucleus. Now here you can see group 1. Okay. Now in group 1, one electron is there in the outermost shell. As the group is 1 and its Roman number is first A, so as it contains one electrons in its outermost shell. So likewise only the arrangement of electron is there. You can see in the middle nucleus is there and around it electron is there. Okay, so one electron is there. After that, for the second period, lithium is there. Okay, in group 1 only. Okay, so group 1 consists of one electron in its outermost shell. You can see that in lithium also one electron is there in the outermost shell. The red color circle is the outermost shell. Okay, so lithium consists of in that red color shell, in that outermost shell, one electron is present. For sodium also same case, one electron is present in the outermost shell. You can see the red color circle is there around the sodium. Okay, so here we know that the hydrogen is having the atomic number 1, lithium is having the atomic number 3, and sodium is having the atomic number 11. Okay, so here one electron is there in all the elements, whatever the elements which are present in group 1, all elements contains one electron in its outermost shell. Okay, then comes the group 14. Now group 14 is the carbon family. So yesterday only I told you, see the carbon family, group 14. So this will be your um, fourth A group. So fourth A group, that shows that 4 electrons should be there in its outermost shell. So here the red color circle is the outermost shell. Carbon contains 4 electrons in its outermost shell. Outermost shell is shown by red color circle. So it contains 4 electrons. Then same way silicon also contains 4 electrons in its outermost shell. So this shows that whatever the group may be. Okay. Now here group 14 consists of 4 electrons in its outermost shell. So whatever the elements which are present in that particular group, okay, in that particular group, one below the another, it contains 4 electrons in its outermost shell. Okay. After that, 17th group, that is halogen group, is there. How many electrons should be there in the outermost shell? It should contain 7 electrons. Okay. So here 7 electrons are there in its outermost shell for fluorine also and for chlorine also. You can see this diagram. So the red color circle is the outermost shell and it contains 7 electrons. Chlorine also contains 7 electrons in its outermost shell. So whatever will be the elements present in that particular group contain same number of electrons in its outermost shell. Okay, mark these words. Then 18th group contains, they are fully filled. Okay, they are fully filled. So all whatever the shell is present, they are all occupied and they are the most stable elements. Okay. So here You can see they are all, the shells are completely filled. So likewise, you can say that whatever the elements which are present in that particular group contain the same number of electrons in its outermost shell. Okay. So groups, there are 18 vertical columns in the periodic table. Each column is called as the group. So all the elements in a group have the similar chemical and physical properties because they have the same number of valence electrons. Both the chemical properties is also similar and physical properties are also similar. So then after that, periods in periodic table, elements are arranged in a series of rows. So elements of the same period have the same number of electron shell. Okay, so whatever with the rows, okay, periodic table is there. Okay, it contains the same number of electronic shell. Now here you can see period 2 is there, lithium is there. Okay, now lithium contains, outside of that nucleus, one gray color circle is there. Not only for the lithium but for the carbon also, fluorine also, and neon also, you can see. Okay, so that gray color part, that and that red color circle. Okay, so the number of electronic shells are similar. You can see here two shells are there, one gray color circle and red color circle for period 2. Okay, then carbon also contains two shells, fluorine also contains two shells, and neon also contains two shells. So the number of shells will be same for a period. Okay, so always remember, if period is there, the number of shells will be similar, and if group is there, the number of electrons which are present in the outermost shell, that will be similar. Number of electrons you have to consider for the group and number of shells you have to consider for the period. Okay, you can see the third period. Now in third period, how many shells are there? 1, 2, 3. Two gray circles and one red circle. That is 3 shells are there. 3 electronic shells are there. Same 3 electronic shells will be for Si, Cl and Ar. Okay, that means silicon, chlorine and argon. 3 number of shells are there. So the number of shells will be equal for the period, and the number of electrons present in the outermost shell will be same for the group. This is the similarity. Okay. Then classification of elements. So group 1 contains alkali metals. Okay, so here you can see here one of the table. Group 1 contains the alkali metals. Okay, so from red color it has been written upwards. You can see alkali metals. So all that red color elements, they are all alkali metals. Okay, then it contains Li, Na, K, Rb, Cs and Fr. So the alkaline earth metals are the metallic elements found in the group 2 of the periodic table. So here you can see group 2, 2 is written above beryllium. So this is the alkaline earth metals. So here all whatever the elements are present, they are all alkaline earth metals. Then elements present in group 3 to 12 in the middle of the periodic table, they are called as transition elements. So here you can see from group 3 to 12, these are all the transition metal elements. Okay, so these are all the transition metals. Then after that, you can see that in the transition elements, valence electrons are present in more than one shell. Okay, so in the transition elements, valence electrons are present in more than one shell. You can see here. So this is the most systematically arranged modern periodic table where you can see each and every element properly, and whether they are metals, they are non-metals or metalloids. You can see here. After that, group 18 on the extreme right side position contains noble gases He, Ne, Ar, Kr, Xc and Rn. So their outermost shell contains 8 electrons except helium, as its outermost shell is K shell and it can hold only 2 electrons. Okay, we can see here 18 group element. Helium contains 2 electrons, as its atomic number is also 2 and it contains 2 electrons which is fully filled. After that, inner transition elements, 14 elements with atomic number 58 to 71, that is Ce to Lu, are called as the lanthanides, and they are placed along with the element lanthanum, that is La. The atomic number is 57 in the same position. Group 3 in period 6, because of the very close resemblance between them. You can see here lanthanide series La2YV. Okay, so here this is the lanthanide series. That means after you can see in period 6, okay, BA56 is there, and after that La should be there, but their vacant spaces have been placed and so many elements are there, so that's why it is written below. So we can't consider it in that particular table, because if we put all these elements there, then whatever the transition metals will be there, they all will get disturbed. So that's why we placed it below. 14th elements with atomic number 90 to 103, that is TH to Lr, are called as the actinides, and they are placed along with the element actina, that is AC. The atomic number 89 in the same position. So group 3 in period 7, because of the very close resemblance between them. Okay. So this actinide and lanthanide series, they are placed one below the another. So you can see here after Ra, here after the radon, you can see AC is there. Okay. So AC, after that, whatever the elements are present, they all resemble to each other, and these are lanthanides and actinide series are also known as the inner transition elements. Okay, now here you can see that the elements beryllium, magnesium and calcium, okay, belong to the group second, and that is the family of the alkaline earth metals there. So there are 2 electrons in the in their outermost shell. So similarly, there are 7 electrons in the outermost shell of the elements such as fluorine, chlorine, and bromine, iodine. Okay, so from the group 17. So these are known as the family of the halogens. So while going from top to bottom within any group, one electronic shell gets added at a time. Okay, from this we can say that the electronic configuration of the outermost shell is characteristics of a particular group. However, as we go down a group, the number of shells goes on increasing. Okay, so here you can see that. Now, group names I have written. One, that is hydrogen and the alkali metals, which is group 1. Group 2 consists of alkaline earth metals. Then after that, 11 is known as the coinage metals. 11th group, you can see here Co, then after that Ag, and after that Au. Okay, so these are the coinage metals, because coins can be made from these metals. That's why coinage metals is given. Then group 12, Zn, Cd, He, and Cn. These are all known as the volatile metals. Okay, they can be evaporated. That's why they are known as the volatile metals. Then you can see group 13, boron group is there. Okay, so whatever the elements are present below boron, they are all known as the boron group. Then after that, as it is placed below boron and they resemble each other, so that's why they are known as the boron group. After that, carbon group is present as they resemble each other and it is present below the carbon, so they are known as the carbon group. Then after that, 7th one is nitrogen family group, we can also say, and also we can say nitrogens. Okay, as nitrogen is there, so that's why nitrogens. So the elements which are present below nitrogens, they resemble each other, and that's why they are known as nitrogens. So then after that, 16th group is present as it is placed below halogens, that's why halogens. Okay, so these are also known as the halogens or the elements of oxygen group. Now here, after that, 17th is the halogen group and 18th is the noble gas elements. Now here you can see the gray colored, whatever the gray colored elements are there, they are all metalloids. Previously we have seen. So here on the left hand side metals are there, and on the right hand side non-metals are there. So that gray colored elements, B, Si, Ge, As, Sp, Te, At. So these are all the gray colored elements. So these gray colored elements are metalloids. Okay, and whatever the elements present On the left hand side of these metalloids, they are all metals, four metals they are. And whatever the elements which are present on the right hand side of it, they are all non-metals. We can say it as moderately active non-metals. After that, the yellow colored, that is nitrogen, oxygen, fluorine, chlorine, bromine, these are all highly active non-metals. Okay, so here these are, so carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, SeBri, so these are all the non-metals. Gray colored, they are all the metalloids, and whatever the blue colored is present, they are all four metals. So in exam, it can be asked that which are the metalloids. So you have to write the names. Then after that, which are the non-metals, which are the moderately active non-metals, which are the highly active non-metals. You can take the screenshot because this is very informative periodic table where you can understand what which metal is an alkali metal, which is a lanthanide series, which is a transition metal. Then for each group, specific name is given. So what will be the name? You can see there in the group names I have written which name is given to which group. Okay. So after that comes the unknown chemical properties elements. So here you can see white colored, whatever the elements, that boxes are there white color. These are all the unknown chemical properties. Many of the elements have been discovered, but their chemical properties are not that much known. So we can consider it as an unknown chemical properties. So after that, so this is about the table of the modern periodic table. So for learning this modern periodic table, you can see that hydrogen and helium, hydro first is the hydrogen and then is the helium. Okay, after that, Lee Baber Canofny, this is one of the short trick to learn the periodic table. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So Lee Baber Canofny. Okay, in this way you can learn it till neon. Li, Li means lithium, Be means beryllium, B means boron, K means carbon, No, No, that is N for nitrogen, O for oxygen, No, F means fluorine, and Ne means neon. So likewise, this is the short trick to learn the periodic table, Liebig Canofny, and you can count it with in your hand. The number of atomic number is there, and these elements are placed according to the increasing atomic number. So starting from 1, so first is the hydrogen, then helium, after that lithium, beryllium, that is Liebig Canofny. Count it in your hand. You will get this number of atomic number of that particular element also. Okay, if you count from Liebig, that is lithium comes third. So Liebig Canofny, for till carbon, it is sixth finger is coming. So that's why it contains the atomic number 6. So likewise, you can also count the atomic number, and as well as you can also learn the series of the periodic table. After that, from sodium to argon. Now, in Marathi, you can Marathi, Hindi, English, whatever language is suitable for you, you can make one story with these elements, and you can serially you can arrange the elements. So you have to apply different trick to learn the periodic table. Okay. Likewise, one of the example I can give you, sodium and NaMg. Okay, namaste. You can consider it as a namaste, NaMg. Then ALSI. Namaste Alsi, ALSI. Okay. Then P for पडून जात होता, S for सोडलं नाही, and CL clap करायला लागले, and A for आरडाओरडा करायला लागले. This is in Marathi language. I just made it to recall all the elements in the periodic table. You can also make it by your own. So make few stories, make song, whatever you can make with this periodic table, so that you can memorize whatever the elements are present in the periodic table. So you have to apply your short tricks. Okay. So this was all about the modern periodic table. So I hope you have understood about the periodic table, and you can learn till krypton. That will be enough for you. And whatever the elements, count it from your fingers, and learn the name of the elements, and the atomic number. If you will learn the name, if you will make short trick, then it will be definitely easier for you to know the atomic number of that particular element. So now let's evaluate. So tell me, can anybody name the element of alkali metals? Alkali metals, as you know, that they are present in the S block elements. So name name any two elements of the alkali metals, whatever you know. Yes, Khushbu, unmute yourself.
Ma'am, hydrogen, lithium, sodium, potassium.
Mhm. Good, very nice. Good. Okay. Then name the elements of the alkaline earth metals. Anyone?
Ma'am,
Alkaline
can
earth.
I? Magnesium and calcium.
Okay, magnesium and calcium, right? Okay. Now, next question. Name four transition elements. Transition elements means the middle one. Okay. So any four transition elements you can tell. Whatever. Yes, you can tell. Sakshi Verma.
Ma'am, magnesium, iron, nickel, copper.
Okay.
Kobar.
Okay, okay. Good, nice. Okay, then after that, name four halogen elements. Yes,
Miss,
Sakshi.
can I?
Sakshi will tell now. Sakshi Verma, Kushbu, Kushibano,
Yes, ma'am. Iodine,
mute,
chlorine,
mute your,
fluorine.
Kushi, Kushibano, mute yourself. Sakshi, tell me the answer. Unmute yourself. Or Anjali.
Miss, can I? Yes, Miss.
Yes,
Fluorine, chlorine, iodine.
yes. Bromine. Okay. So these are all the halogens. I hope this lecture was useful for you. Okay, and all you have all answered good, all of you, and study it, and we will continue it tomorrow also. Periodic classification of elements, and we will see the other part of this topic. So thank you everyone, and thank you BMC Education Department for giving me this opportunity. Thank you so much.